right. We left off looking at Desmos and all the different transformations we can do with the sine and cosine curves and how each variable here or each factor kind of affects different characteristics of my sine cosine curve.
Yeah, right here.
So today we're going to actually graph some, but as a little baby step, we're just going to practice finding the amplitude and period of these different types of functions. And as I mentioned, there's lots of patterns with these, so they actually aren't too bad to graph once you can recognize the patterns. And the better you understand transformation, the more this just makes sense, and it's less about memorizing, more about your conceptual understanding. Okay, so amplitude is the distance from the middle of your graph to the max or to the min, for that matter, because it's going to be the same. And it's if we have a vertical stretch or shrink factor. So here, number 1, my amplitude is just 3. Okay, because normally it's at 1, vertically stretched. You don't even have to tell me that. It's just that number in front. It's the absolute value of that number, because if it's negative, that means a reflection. Okay, now, there is that little formula I gave you to find the period that you can just do 2 pi divided by b, but I'm going to get you started in a habit. This is that thing I was talking to you about that I learned from that college professor that is going to make your life easier when we go to graphing. So what you're going to do, and this works for any horizontal transformation, stretches and shrinks, or shifts, you're going to take what's ever going on with the x, just the x, not this number out here, and you're going to set it up in this inequality from 0 to 2 pi, because that's normally where my period starts. Okay? So you'll set this up, and then you'll solve this for x. This one's pretty easy to solve for x. I got to times everything by 2. And this will give you your new starting and ending position of any horizontal transformation. So here, I had a horizontal stretch, so you can see my period got bigger, right? Now remember, period refers to the length of one cycle. So if this starts at 0 and ends at 4 pi, what's that length? 4 pi, there's your new period. Which would be the same thing we would do if we just did 2 pi divided by 1/2 divided by b. That's the shortcut way of doing this, but this will help you once we get to shifts. Okay, what would my amplitude in number 2 be? 2. Perfect. Amplitude is 2. The period, you take anything that's going on with the x and set it up in this inequality. So you always want to start, for sine and cosine, you always want to start with 0 and 2 pi because that's their normal period. Now, to solve this for x, we want to divide everything by 2 pi. So now this new function is going to start at 0 and it's going to end at 1. That's okay. What's that length?
1.
1. That's your period. Okay, not too bad, right? Let's do one that's a little harder. I'd hate to bore you. Oh, it's fine. It's fine. Your words don't hurt my feelings.
I wasn't aiming for those.
All right, what's the amplitude in number 3?
4/5.
4/5, not negative. 4/5. Amplitude is always positive. Negative means it's going to be reflected. Amplitude is the absolute value of A. All right, this period, we have a little bit more going on here. I have 3x minus pi. So all of that goes in your inequality. To solve this, first I'd add pi to all 3 sides, if you will, of this compound inequality. Yes, 2 pi plus 1 pi is 3 pi. Oops, I almost forgot to add pi. Oof. Okay, then I got to divide everything by 3. So now we can see
Only 1% bad pi over 3.
the period, yes. Yep, now we can see this one has a little bit of a phase shift, as we call it. Now it's going to start at pi over 3 and finish at pi, okay? And that's because I have a little horizontal shift here to the right?
Right.
But this length, Ashton said 2/3, so 2 pi over 3, that would be my period. Good. That distance, 2 pi over 3. Everybody okay with that math? 1/3 to 1 would be 2/3. Last one. Amplitude. 2. Period. Pi x over 12. Okay, you can do this in 2 steps. You can times everything by 12 and then divide by pi, or you can just times by reciprocal. Times by 12 over pi. Okay, if that confuses you, don't do it. You'll get the same answer. If it's easier to do it in 2 steps, totally fine. This one's now going to start at 0. The pi's cancel. It's going to end at 24. Which, think about that. Pi over 12, it's a pretty small fraction, so that's a pretty big horizontal stretch. This got really stretched out. My new period is what? 24.
24. Yeah.
24. Okay, so sometimes your period might be in terms of pi, sometimes it might not be. That's why like those that graph paper for sine and cosine is nice, but that one is like strictly in terms of pi. So honestly, I think it's like easier just to use normal graph paper, but it is nice because it's just like sectioned off like this. I like pasted just a little piece of graph paper on here for you to graph. Okay, 1, 2, 3, 4. We're gonna graph a total of 8.
Disgusting.
So think of this as level 1. Because there's a lot of different things we need to look at. Okay. Sketch the graph of the function. Include 2 full periods. So basically, the 2 characteristics you want to find right away when graphing is the amplitude and the period. If you know those 2 things, which we just practiced finding those, then you're golden. So here, in this example, what's my amplitude?
4.
4. Perfect.
4.
That is going to be how you count up on the y-axis, because that's referring to how tall my graph gets, right? So if I gotta get to 4, obviously I'm just gonna count up by ones. So your graph should not go higher than 4 or lower than -4. Now keep in mind my midline is at the x-axis. Can anybody tell me how I know that?
There's no like shifting or subtracting.
Nice, Max. There's no vertical shift, right?
Yes,
Oh,
Jesus.
let's go. Just math is fun.
I had 3 raids in AP Psych 2 today, and that's not normal.
There's no vertical shift here. Okay? So my midline just stays right there at the y-axis. The only time that changes is if we shift it up or down. Okay. Good. So my midline is here. You don't have to draw on your midline if you want to. You can, but there's my midline. Okay. Period. Set up your inequality. You're starting off with a pretty easy one.
It's not that easy.
Yeah, it
Takes you a
is.
while.
Just pi.
It all depends on
Okay. Now the reason why this is helpful is this tells you where you want to start your curve and where you want to end your curve. Now, keep in mind we have to graph 2 full periods on here. Okay, so I'm not going to like call this way over here pi because I could only fit 1 period. So a really easy way to do this on my like kind of section of the graph is what I do is I like count like 8 boxes, so it's like about halfway, and call that pi. Okay. I like to do it in 8 boxes because that's really easy to find halves of. If you count over like 3 boxes, it's hard to like half 3. So then halfway, like 4 boxes here would be what? Pi over 2, exactly, good. Okay, so then another 4 boxes would be 3 pi over 2. And another 4 boxes would be 2 pi. And I know 1 period is a length of pi, so this will fit my 2 full periods. Okay. All right, now we're pretty much ready to start plotting points. So the next thing that I'll look at is, are we graphing a sine or a cosine curve? Sine. Sine starts at an intercept, and after 1 period, it returns to where it started. It ends at an intercept. Okay, here's kind of the pattern for sine. Starts at an intercept, ends at an intercept. Halfway, crosses again. Okay, so it's going to cross, in this case, at pi over 2 and 3 pi over b. Yeah, I'm just going to graph one period first. All right, now the other pattern with these, because they're like curvy like this, halfway between the intercepts, we have maxes and mins. All right, so that's another reason why I like to count up by 8s, because we just found half of 8 is 4, and I got to find half of 4 is 2. So this is a sine curve. It goes up to a max of 4 in this case. That's my amplitude. Crosses halfway between these, which would be 3 pi over 4. You don't have to mark all of that. It's going to cross. So here's one full sine curve. Does this have an amplitude of 4? Does it have a period of pi? Yeah. Okay, we're good. So then to graph your second period, you just do the same thing. It's repeating. So many patterns. It's going to start where it finishes. Halfway, intercept. Halfway of those, max and min. And then just draw arrows. So this goes on forever. And that's it.
This is amazing.
Really quick, let's talk about domain and range.
Domain is all numbers.
Domain is all real numbers. Good.
And range is 0 to -4.
It's -4 to 4.
Good. Range is -4 to 4. Brackets or parentheses? Brackets, including those points.
Include.
Yeah.
Okay, that's level 1. Not too bad, right?
That was atrocious.
Stay there.
Level 2.
Are we gonna get to shift them?
Yeah, we will.
Let's hope
Probably.
not.
I don't know. We'll see. Okay, level 2. Actually, I like to zoom without screen. Amplitude for this one. 3 halves. Okay, so if I were you, I'd count up by halves. Call this 1/2, 1. This is 3 halves. And that's a nice thing about graph, like I'm saying, like your own graph papers, you can manipulate the axis. And it's like really especially nice for the x-axis when our period changes. Okay. And you don't have to label everything, guys. Like, I'm pretty okay with you. Well, it has to make sense. Like, you can't say, like if you wrote this, I would take off points because you're like, okay, that spacing doesn't make sense. If that's -1, you can't have -3 halves down there, right? So as long as I can see, like, oh, they're counting up by halves and you're spacing, then I'm okay with it. All right, period. Yeah, I would times by reciprocal, or you could divide by pi over 4, but I don't like to divide fractions. I like to times by reciprocal.
Oh.
Okay, the pi's cancel. 2 times 4 is 8. So my period here is 8. So this needs to start at 0 and end at 8. All right, now, again, we have to graph 2 full periods. So I count over 8 boxes. 2, 4, 6, 8. Call that 8. 8 more boxes. Call that 16. All right, from there, I would at least label the halves. So halfway would be 4. So this one just ended up counting up by 1s. And like I said, you don't need to label every single one for me, but that spacing makes sense. Again, you can't like call this 10 and then call this over here 12. It has to like make sense. So we have another sine curve. Starts at a 0, ends at a 0. Halfway,
2.
intercepts. Halfway is 2. Now, careful here. What does this negative do?
Flips the whole graph.
Reflects it. So instead of having a max at 2, what am I actually going to have? A min. This one's going to go down and then up. So you got to watch out for that. And then this one's going to have a max. So there's one sine curve. Amplitude of 3 halves. Apply my reflection. Period of 8. One more. Repeat. repeat that pattern. And of course, arrows. Domain, all reals. Range, -3 halves to 3 halves. Good. Okay, so they want to look at one reflection one because that's different. That was level 2. Are you ready for some cosine ones?
Level depression, that's what it is.
Oh, that's so negative. It's so sad. 2022, new year, new positivity.
Oh.
New year,
False.
new me.
New year, new positive.
Okay, let's try some cosines. Level 3.
DNA.
Same exact process. The only thing that's going to change is basically like where we start and end. With the cosine has a little different characteristics. All right, so what's my amplitude for this one? 2. Good. So I like to space things out, so I'd probably do this. I like to use up as much graph as I can. If you call this 2, then you have like this really tiny like curve, which is like fine. I mean, but try to use as much as your graph as you can. All right, period. I would times everything by the reciprocal, so times by 3 halves. Or divide by 2/3. So that would make that, 3 pi. That's my period. Length is 3 pi. Here's where we're going to start. Here's where we're going to end. Okay. So 8 boxes over. Call that 3 pi. Oh, that was locked. Nice. What would half of 3 pi be?
1.5.
3 pi over 2.
3 pi over 2.
Oh, Lord.
Label that. So that another 8 boxes would be 6 pi. What would be halfway between those? Nope.
No, I pi over 2.
You can count halves. 3 halves, 6 halves. 3 to
9
6.
Oh.
9 halves. 9 halves, 12 halves. It's all fractions. Radians, all fractions. Okay, we're ready to do points. The only thing that's different with cosine is it doesn't start at an intercept. It starts at a max. Ends at a max. Okay, I said that's like our big difference. Starts at a max, ends at a max. So this one starts here at a max. Starts at 0. Ends at 3 pi, so it's going to end where it started. All right, same patterns for cosine. Halfway between these is a min. Halfway between the mins and maxes is where it crosses. So it looks like this. Make it curvy. There's one full cosine period. It's a little bit harder to visualize, but that is one full cycle, right? Starts up here, down, finishes there. So really it would cross at like 3 pi over 4. And we continue in that pattern. So starts up here to max, finishes at a max. Halfway is a min. Halfway is an intercept. Arrows. So with your labeling, I'm good with this. Like label all those. If it asks you to find the x-intercepts, you just have to do a little bit more fraction work, right? Like that, what's half of 3 halves? 3/4. So 3 pi over 4, 6 pi over 4, 9 pi over 4, right? 3, 6, 9 pi over 4, etc., etc., etc. Domain?
Always.
Range?
-2 and 2.
I think the directions on the homework are the same as this, like sketch the graph and you have to include 2 full periods. Okay, that was level 3. Level 4. What jumps out at you right away with this one?
This is negative.
It's a negative, so we're gonna have to reflect it. So sometimes because it's easy to forget that, sometimes I'll just like circle this and like reflect or flip or just do like an R or something like that. Like write down like, hey, don't forget we are gonna have to reflect this. All right, my amplitude, 4. That's easy just to count it by ones. My y-axis. Period. It's going to be 1. Okay, it's going to start and end.
Go start at the -4.
Start at -4. Oh, yeah, once we get to the points. Yep. Okay, 2, 4, 6, 8. Call that 1. Half of 1 is obviously half. So this would be 3 halves and 2. Okay, yes, max is exactly correct. Instead of starting at a max, we're going to start at a min. We're going to start down here at -4. So after 1 full period, if it ends at 1, we're going to end where we started at a min. All right, here's the pattern for cosine. Halfway between those, max. So at 1/2, there's a max. Halfway between those, crosses. Crosses on 1/4 and 3/4. Okay, then we just repeat that pattern. Okay, so those are pretty basic examples. Now we're gonna do some like phase shifts where they get just like a little bit trickier, but it's the exact same like process. The only thing that maybe makes this a little bit trickier is sometimes you have to be a little more cautious of counting on your or scaling on your x-axis because now we aren't gonna start at 0. Okay. We're already halfway through the levels. That was level 4.
Halfway through the levels.
Yeah.
Yeah, that was like the beginning of recording with
Yeah.
No.
Do I sound like that?
God.
No.
Sound like a witch. All right. Level 5.
Ooh.
What's my amplitude?
God.
I don't know, I need to flip the page.
Explain this.
2/3, and right away what jumps out at me is, ooh, I gotta reflect this. So I would count it by thirds. Well, we could do this. Count it by sixths. 1/3, 2/3. I would never do that. Space it out. I did not do that on my paper. That's okay. That's the fun thing, is you get to manipulate it. You get to decide. Okay, period. Same process. First thing I would need to do is add pi/4 to everything. There's my shift. What's 2 pi plus pi/4? 9 pi/4. Good. Then I would have to double everything to get rid of that divided by 2. So careful here. 2 times 1/4 is 1/2. 9/4 times 2, 9/2. So now here I'm going to need to start at pi/2 and end at 9 pi/2. But what's that length? 8 pi/2, which is 4 pi. Okay, so here you have to be like a little bit more like I said, conscious, I guess is a good way to put this, of like what you count up by. Because now we have to start at pi over 2. We're not just starting here at 0, so you can't really like use that 8 box method unless it works. But for example, like I can't say like, oh, this is 9 pi over 2. Oops, that's the wrong box. You can't say 8 boxes and 9 pi over 2 and then call this pi over 2. That scaling wouldn't make sense, right? Because if you're counting up by pi's over 2, that would technically be 8 pi over 2. So that's what I'm saying. Just be a little bit more conscious. This would work. Like we can count up by pi's over 2, but then this one right here would be 9 pi over 2. And this is good spacing because I have to fit 2 on here. So we're still like using the 8 boxes, but just be careful with how you're counting up and make sure it makes sense. Okay. So there would be halfway. What would half of 9 pi, or what would half, I shouldn't say of 9 pi over 2, half of this distance be? Think about it, counting by pi's over 2. So 1, 2, 3, 4, that'd be 5 pi over 2. How am I thinking? 1, 2, 3, 4, 5, 6, 7, 8, 9. That scaling works. Okay. So keep along with that pattern. Another 8. 9 pi over 2, 10, 11, 12, 13, 14, 15, 16. That'd be 17 pi over 2. Or you could just add 4 pi to that. All right, what would that halfway mark be? Nope. 9, 10, 11, 12, 13 pi over 2. Does that make sense how I'm counting that? And that's different every time. That depends on what your period is. Yes, we have to start at pi over 2. We're not going to start at 0.
Wait, so do we not just put in can we just start it and at 9 pi over 2? We don't have to like put one right after that.
We're going to start here and end here.
So then you
You
just
shifted
like,
it all, otherwise it was
so
supposed
that's
to be
your
4 pi.
second curve.
Yep.
Like,
It's going to start here and end here.
okay, that makes sense.
Yep. Okay, now it's cosine. Cosine starts at a max, but it's reflected, so it's got to start at a min. Starts at a min, starts at pi over 2, ends at 9 pi over 2, ends where it started. What's halfway between the mins for cosine? What type of point? It's 5 pi over 2, but it's a max. Yep, that's what I was looking for. Halfway, which would be like right here, 2 boxes, it crosses. So there would be 1 cosine curve for this one. Now, yes, we got to do 2 periods. So it's going to start here, end here, halfway, max, halfway, crosses. Draw arrows. So this one we don't know what the y-intercept is. I know the domain is all reals. And the range is negative 2/3. The reason why I'm having you do domain and range is because it does change when we do a phase, or not a phase shift, a midline shift. I just want you to be like a little conscious of it. Okay. We'll do one more phase shift like this. These ones I think are the hardest, the phase shifts. Okay. Level 6. Amplitude?
1/2.
1/2. You could honestly do this and I'd be okay with it. Counting up by force. No, we're not. Counting up by eighths. Okay. That's good. Period. I mean, just obviously, like, no, guys, like, this is obviously going to be, like, a pretty, like, because think about it, that's a vertical shrink, right? This is going to be a pretty small curve if that distance is half. All right, to solve this for x, I would add pi over 2 to everything. That would give me 5/2. And then I would divide everything by 2. Careful with your fractions. That would give me pi over 4 is my new starting. 5 pi over 4 is my new ending. What's that length?
Pi.
Good. Pi. Good fraction. 1/4 to 5/4 would be 1. Pi. Okay. So another thing you can kind of do when you're doing these is just test some things out. So if I count up by pi's over 4, don't write this down. 1/4, 2/4, 3/4. Oh my gosh. Hold on. I have an undo button that I discovered. Lock. 1/4, 2/4, 3/4, 4/4, and you're like, okay, there's 5/4. This is fine, but that's pretty small, right? We want to try to use as much graph as we can. I want to take points off this. This isn't wrong to count up like that. So then I maybe try, okay, let's call this pi over 4. 2/4, 3/4, 4/4, and then 5/4. I'm like, okay, that looks a little bit better. And then it's easier, like I said, to do kind of halves.
So, how come you can jump count different versus us?
As long as you're being consistent. So technically, I'm counting up by ace then. And as long as you're consistent with it, you can kind of manipulate. Does that make sense? But what I was saying is don't say this is pi over 4. Okay. Don't say this is pi over 4 and then say all of a sudden oh yeah, over here is 5 pi over 4, because then you're not counting up by ace. It has to make sense. I will say I feel that's the hardest part for students. Sometimes just scaling the x-axis, not even the graphing part. So if that's 5 pi over 4, another full period, so I'm 1/4, 2/4, 3/4, 4/4, 5/4. Oh my gosh. 6/4, 7/4 would be halfway. 8/4, 9/4 would be where that second period ends. I guess I could label this too, the halfway here. 1/4, 2/4 would be 3/4. Okay, throwing it back to sine again. So I gotta start at pi over 4. Sine starts at an intercept. I gotta end at 5 pi over 4. End at an intercept. And then my pattern for sine, halfway, crosses, halfway, it goes up, reaches a max. I don't have a reflection. Down, reaches a min. There's one full sine curve. That fits all my criteria. Fits the amplitude, has the correct starting and end position. We call that a phase shift. And has a correct period. That length of that cycle is pi units. See, it's not too bad, right? Once you kind of recognize, like I said, there's lots of patterns. That's why these are nice. Ooh, we could figure out this one crosses down here.
No.
Jeez. Just if you want to be a little bit more accurate, we can keep going. It scared me. Domain. All reals. Range. Negative half to half. Can we do all 8 levels today?
No, I think we should stop here.
Question, Carter?
Where did you start the graph?
Sorry, I just added it in. I started it here. Sine starts at an intercept.
But, okay, but where did you start?
That's cosine.
Yeah, I was like,
This is sine.
Oh, okay, yep.
Okay. Last level. We're going to throw in a phase shift and a midline shift. Okay. This is level 7. There's only 2 left. 2 levels left.
Wait. There's a level 9?
No, 7 and 8. All right, so these midline shifts are kind of like the reflections. When you look at this, what should jump out to you first is, oh, man, I have a shift up 3. So that's going to make your midline change. I haven't been drawing my midline in because for everyone we've done, it's just been the x-axis. So now my midline is at y = 3. before you draw in your midline, pay attention to what your amplitude is. My amplitude is 2. So what that means is when I'm scaling my y-axis, if I do decide to count up by ones, just make sure you can still go 2 above that, which we can, would be 5, and 2 below, which would be -1. Let's go ahead and draw in our midline there. So folks, it's the exact same from here, just like think of that as your new x-axis. Okay, think of that as your new x-axis. Yeah. Oh, I think I just drew an extra dash. Sorry. Yes.
Excuses.
At 7.3 there, can I put a 0 there?
That looks like -3 too, doesn't it? Sorry.
And then can I label the 5 as 2 and then the 1 as -2?
Like you're calling this 3, you're saying?
No, I'm calling where 3 is 0. Can I make that my new 0?
Why would you do that?
Because that's my new x-axis.
But then everything's like gonna be like way up here. Hang tight.
That's what I'm kind of, yeah.
Yeah, hang tight. Let's finish this and then maybe you'll see it once we actually draw it in. Okay, for period, same thing here. No horizontal stretch or shrink. It looks like just a shift to the right. So I'm just gonna have a new starting and ending point. Well, my period, you'll notice, doesn't change at all. So I'm gonna start at pi/3. All right, team. What's 2 plus a third as an improper fraction? Good, 7/3. So that length is still 2 pi. And we didn't have a b, meaning a number that's being timed to the x. So that means there's no horizontal stretches or shrinks. But I do have to start at pi/3 and end at 7 pi/3. So this works out pretty nicely to just count up by pi's over 3. So 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3 would be there. So this time I only use 6 boxes. If I were to try to scale it bigger, then I would run out of room for my second period. Okay, so that's okay. We can still easily find half of 6. But again, I can't do this and then count 8 boxes and say like, oh yeah, there's my 7/3, because then that scaling doesn't make sense. Because 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3 would be here. So you can't always just use 8 boxes. Does that make sense?
Yeah.
That's okay. Halfway is here. What would halfway be in this case? Count up by thirds. 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3. Okay, so there's gonna be 1 full period.
How do you find the half of that?
How would you find half of this? It's just gonna have to be like in between these two. And you don't have to label on your x-axis, but we will have to put points there. Yeah, it's okay. In real life, if you had more graph paper to work with, you probably could still count up by 8 boxes, and then it makes your life easier. But in this case, if we were to try to space it out like 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3, we're gonna run out of room. Okay. So it's probably, like I said, it's easier to do on your own graph paper. All right, so 7/3, 8/3, 9/3, this would be 10/3. Isn't it nice just keeping everything in improper fractions? 11, 12, 13/3 would be where that second period ends. Okay. Now that we have everything scaled, we're ready to start drawing the points. Again, our midline, think of this as our new x-axis. Do we have sine or cosine here? Sine. Sine starts at a what? Intercept of the midline. So it's going to start here at pi/3, end at 7 pi/3, and an intercept. Halfway, intercept. Not actually an x-intercept, intercept of the midline. I should phrase that better. Halfway, so yeah, this one isn't a nice, easy one. 1.5. We would do a max. They're at 5, because my amplitude's 2. And then halfway between those, min at 1. 1.5 boxes again. So here's one sine curve. Okay, Max, does that make more sense with your scaling question?
What?
After you finish, I'll just show you.
Oh, okay. Sounds good. All right, I gotta do that one more time. Cross, cross, halfway, max, halfway, min. So there just wasn't quite enough room to count up by twos that time, but that will work. Domain is still all real, but what's my new range? 1 to 5. Good. So some people get stuck in like the pattern of, oh, my range is always just my amplitude. Not always. Yes. I'll go back. We'll stop there. Let me just stop it. We made it through level 7. We will save level 8 for tomorrow. But do some practice on your homework of graphing these ones, especially the basic ones.